Hey guys, we're going to look at a foolproof way to both memorize and then use formula to calculate the basic variances from your performance management exam. Specifically, we can use this for the direct materials and the direct labor variances. Okay, I'm going to take you through part A1 of question Kappa from the December 18 exam to demonstrate this. Okay, check out that question, give it a try, dig around in there so you can follow along. Alrighty guys, if I see any question that asks for the basic variances of direct maths or direct labor, I'm going to deploy a set of letters. Okay, those letters go in alphabetical order. Okay, AA, AS, SS. I think we can all memorize that alphabetical order. Now, if we're doing materials, we're going to put into the letters Q and P. Q and P. Q and P. I think you know what that stands for. Quantity and price. Okay, if we're doing direct labor, it's still going to be the amount of something over here and the monetary value. So that would be the hours and the rate. Works the same way. Okay, now let's quickly populate, okay, this system of letters with some numbers. So the actual quantity, can we dig around in the question? We'll be working for material alpha. Guys, let's do this for alpha. Okay, how many kilos of alpha did we use when we made 4,600 kilos of omega? Okay, that's right there. 2200, the actual price that we paid, $1.80 per kilo. So the total that we paid, 3960. That's given to us, by the way. So as you go faster, you wouldn't even need to set that up with those numbers, right? Now, let's come over here. AQ, actual quantity, we found that number. That was the 2200 multiplied by the standard price. Everybody, that comes from the cost card, okay? And we can find the cost card in just about every variance question, right? That's the budget for 1 unit, essentially. The cost card answers the question, how much should 1 unit of output cost? However, in this question, it's 100. Okay, but we'll get to that in a second. We can see the standard price, everybody, is $2.02 a kilo. That gives us what? 4400. Now, here, SS, that is code for flexed. That answers the question, how much should 4,600 kilos of omega cost? Okay. That's essentially the flexed, and I'll tell you about that in a second again. So we need to know the actual output of omega, right? That's 4600. How much should 1 unit take? Well, that's 40 for 100, so I would divide that by the 100 units, okay, multiplied by that $2 per unit. Okay, that gives me 3680. Okay, stepping back, look at this. Okay, so we have calculated our variables. What do these numbers mean? AA, everybody, that is code. Actual quantity, actual price. That simply tells us the actual spend. How much money came out of my pocket when I bought the stuff that I used? Okay, SS, that is code for flexed. How much should come out of my pocket? And we will be moving from right to left, answering the question, should cost, did cost. So we'll go from the flexed to the actual. Okay, now, I always remember that my friend, the production manager, his name is Pete, he's always standing here on the right. That's where he hangs out. Pete's in charge of usage, okay? How much material did his guys in the factory use? That's the usage variance, okay? And the other guy, that would be the procurement manager, He's in charge of the price variance, okay? Now, the exam is only asking for this variance, guys, but I'm showing you the full system, okay? This is the full system, more than you need. I would only do this bit on the right in the exam. So, you guys, we did our variables. We remember Pete is on the right, and now we just start moving from right to left, asking the question, how much should it cost? How much did it cost? To be more specific, when Pete makes 4,600 units of omega in his factory, he should use 3,680 worth of materials. He did use 4,400 worth of materials. That's an adverse variance. He used more than expected when he made his omegas. Okay, the difference there being 720. Adverse. Okay, why is it adverse? Okay, because it's like that. The number on the left is greater than the number on the right. Now, if we move over here, okay, when we go to the store and we buy 2,200 kilos of alpha, we should spend 4,400. We did spend 3,960. We spent less than planned. Everybody, that's going to be a favorable variance for sure. Okay, and what's the difference? That looks to me like a 440. Alrighty, check that out. We've calculated our basic variances. Okay. Can we interpret these numbers? Well, we did it before. We'll do it again. When we make 4,600 omegas, okay, we should spend 3,600 on alpha. We did spend a little bit more, 3,960. Well, can we drill down and see what happened? Sure we can. Okay, well, we used a bit more than expected. Okay, we used a bit more than expected. That accounts for 720 of overspend in our P&L. However, we had a recovery, right? We paid less in the store. We paid 440 less than we expected. Okay, now in that exam, they only wanted this part from you, so you could have gone much faster, ignoring the bit on the left. That's all you needed to do. There you go, guys. So, foolproof way to memorize your formula for basic variances. AA, AS, SS. AA, actual spend. SS is flexed. We move from right to left. Pete stands on the right. Pete's in charge of usage. You guys, that was for the component, the material alpha. You guys can use this exact system and you can do the other two. You can do beta and gamma. Give that a try and you'll see that you get the same number as the model answer. Alrighty, guys. Have a go at it. I'll come back and we will try it in the CBE environment next, and you'll see how we can fly when we're using the spreadsheet tool.